Hi, I am Anindita Das Bhattacharjee. In this video lecture, I am going to cover Symbolic AI and its application, Symbolic AI versus machine learning, logic, symbol, knowledge-based relation, propositional logic, tautology, contradiction, and truth table. Knowledge is one of the key factors to make a machine or agent intelligent. We as human beings start gathering knowledge since childhood and also learn how to use those knowledge for making a decision. So we would need to find a way such that knowledge could be incorporated in machines. Hence, knowledge representation is one of the crucial aspects to make a computer read and interpret the surrounding environment in order to take decisions just like a human being. Computers are logical machines that use math to do calculations. So, logic was an obvious choice for the general problem solvers problem solving technique. Back in 1959, Newell, Simon, and Shaw set out to build a computer program that simulates how human thinks to solve problems. Computer program represents real-world object as symbols. That's where the term symbolic AI comes from. And it's how certain AI systems make decisions, generate plans, and appear to think. If you ever applied for a credit card, purchased auto insurance, or played a computer game, then you have interacted with AI system that uses symbolic AI. Modern neural networks train a model on lots of data and predict answers using best guesses and probabilities. Whereas, on the other hand, symbolic AI requires no training, no massive amount of data, and no guesswork. It represents problem using symbols and then uses logic to search for a solution. So, all we have to do is represent the entire universe we care about as symbols in a computer. Therefore, logic is our problem solving technique and symbols are how we are going to represent the problem in a computer. Symbols can be anything in the universe: numbers, letters, donut, cake, Doraemon. One way we can visualize this by writing symbols surrounded by parentheses. Let us now discuss about symbol and relation. As discussed earlier, symbolic representation of this picture is cake surrounded by parentheses followed by a full stop. Is this enough information about the picture? It gives more information if we define it as chocolate cake. Similarly, for donut, we can mention pink donut. And for Doraemon, we can mention cartoon Doraemon in order to capture the more detailed observation. Hence, chocolate, pink and cartoon indicates the relation of the symbol cake, donut and Doraemon. However, relation can also be a verb. For an example, for the sentence Doraemon eat donut, eat is the verb, but here it is the relation between two symbols, Doraemon and donut. One point to note here is more than one symbol are possible in a relation which are separated by comma and end with a full stop. The collection of all truth about the universe is called a knowledge base, and we can use logic to carefully examine our knowledge bases in order to answer questions and discover new things with AI. Not clear? Let's take an example how Siri works. Siri maintains a huge knowledge base of symbols. So when we ask her a question, she recognizes the nouns, verbs, and adjectives, turns the noun into symbols, verbs and adjectives into relation, and then looks for them in the knowledge base. Let's try an example
by converting sentences into symbol and relations. Then try to answer with the help of logic. Here is the statement. Tom troubles Jerry using a big and sharp fork. As discussed earlier, we can convert it in terms of symbols and relations. Here is the representation. Now, Tom and Jerry comes under symbol, troubles, sharp and big comes under relations, and is a connective. We combine this to create propositional logic, and Boolean logic is another name of propositional logic. Let's find out how human brain processes logic to find answers from propositions. In the given example, if fork is actually sharp and big, and if Tom actually troubles Jerry, then the proposition will be sharp fork and big fork and troubles Tom Jerry holds true will be represented as true and true is equal to true. This sort of logic can be understood by human brain. If all three logics are true, then whole proposition is true. However, for an AI machine to understand that, it needs to use some math, where 0 indicates false, 1 or any positive number indicates true, add indicates multiplication or indicates addition. Computer uses truth table as a tool to figure out whether propositions are true or false. Now for the same statement, the representation will be 1 times 1 means true. Just now I have said that any positive number represents true for a machine. So let's try to understand that with this example again, where and is replaced by or. So here is the representation. Now let's create a truth table by considering all the possible situations on. Case 1. If fork is sharp or fork is big and Tom troubles Jerry, then output of the truth table will be 2, a positive number which is more than 1. Similarly, if fork is sharp or fork is not big and Tom troubles Jerry, then proposition is true. Case 3. If fork is not sharp or big and Tom troubles Jerry, then the proposition is false. So this is quite obvious that if the fork is neither sharp nor big, then Tom can't trouble Jerry with the fork and output will be 0. Propositions can have truth value. Truth implies they can be true, will write as T. They can be false, which is denoted by means of F. Propositions may be believed, doubted, may be asserted, or denied. However, the truth value of propositions depend on our world knowledge and the number of additional parameters. Let's take an example. For an example, general content like grass is green is true if content is in line with our basic understanding of the world. Another parameter which can influence the truth value is the speaker who utters the sentence. If a blind speaker utters this sentence, we cannot tell what speaker knows about the truth value of the utterance. Truth may depend on temporal and local content of the sentence in which it is uttered. The sentence is true if the sentence say sky is blue is uttered at daytime. Here we have the example my brother is a rocket scientist. To verify the truth value of this sentence, you need some background knowledge about my brother. This kind of proposition whose truth or falsity does not automatically follow from the meaning of their elements, but it depends on whether they are actually accurate description of reality or not. Let's see how we can formalize sentences in terms of proposition. What a sentence says about the world is proposition. Propositions are labeled with small letters. If you have one proposition, it will be always labeled as P, the first letter of the proposition. If you have two propositions, then use P and Q. Similarly, if you have three propositions, you can use PQ and R. These are the corresponding propositional representation of the sentences provided. Now we will talk about proposition with nil information. Some propositions are true or false by virtue of their meaning, relations, what content in them, regardless of what is the situation in the world might be. Such propositions are called analytically true or analytically false depending on the truth value. Always true statements are called tautology, always false statements are called contradiction. Let's take an example. Either it is a food or it is not food. In the previous example, while labeling propositions, we have learned sentence containing single proposition should be marked as P. Or in this case, the proposition is same preceded by not. Therefore, it is written as not P. Hence, all possible combinations of the truth table are depicted one by one. See all the combinations. The result for each of the combination is true. Therefore, it is tautology, and or is a disjunction known as connective. Again, in this case, either it is food or it is not food, this statement is true, but information in this statement is actually nil. So basically, tautology gives no information. As discussed, we have contradiction means the statements which are analytically false. Now for the example statement, Monday is not Monday. All possible combination of the truth table is depicted and the result of the each combination is false. Hence it is a contradiction and we have used and conjunction which is known as connective. The central means of combining single propositions to build complex one are called connectives. There are 5 such connectives which in natural language are realized in terms of adverb conjunctions. Well, here they are. And or not are already discussed. Now we will talk about implications.